Good morning, ninth grade. Hope you're ready for another good day, another run in math. I think this morning we're ready for 9.13. I got it right? Yes, solving rational equations. You'll work on the same principle as what you do to solve fractions. When you want to multiply numerous fractions, you get the least common denominator. And that's what you'll need to do here, is get the least common denominator to work this out. They've got some examples. You read those examples, you study those. I will try to explain them. Example 5 is a little different, and I will do one problem with example 5. It's another way of working them if you have all x terms. So I'll just start out with number 1. Again, may I stress, if you're working these problems and you don't get it from where I am explaining it, you go and look in the lesson and look at those examples, do those examples to help you. So to start with, it's x3 plus x2 equals 20 over 3. You get the least common denominator of 3, 2, and 3. Well, you don't have to do much figuring, you just 6. Least common denominator is 6. Now I don't need to multiply everything by 6, so I did that here. 6 times x3, 6 times x2, and 6 times 20 over 3. Yeah, I don't know if you want me to waste your time with going through all those steps, but put the 6 on top, 1 underneath, and then x, and then cancel where you can. Can you see that? Yeah, it's just about off your graph. So you cancel, that brings you down to 2x. Do here, 6 cancel the 2, which I did right here. This makes you a 1, a 3, makes you a 3x. So now you have the combination of 3x and 2x. Maybe I should do this side over here. 6 times 20 over 3. You can cancel again here. 6 and 3. And that leaves you with 20 over, wait a minute. 2 times 20 makes you 40 over 1, actually. So that makes you 40. Now I come over here and I combine the 2x and the 3x. Right there we go, is 5x. It was a plus sign here. I believe I forgot. Yeah, right here is a plus sign. So there's supposed to be a plus sign here. In all my figuring, I forgot to put that. But 2x, 3x is 5x over 40. I divided 5 into 5. I said my x, 5 into 40 makes me 8. X equals 8. Now, it does tell you, if you're looking on page 458, there's that little yellow box off on the left-hand side. You need to take note of that. Since maybe you didn't read it, I'll read it to you. The excluded value is any value that causes the denominator to equal 0. Sometimes you get an excluded value. If that is true, then you say it's not a valid number. So what I'm telling you is, when you get done, you've got to check it. Okay, you have to put 8 up here in this block right here, and you have to say 8 over 2 is going to make me 4, and 3 over 8 would be 2 and 2/3. So you would have to add those up and see if that equals 20 over 3. Okay, you need to check them, and I'm not going to go to the work. I'll just tell you that x can be. But if x would have been here on the bottom term, and it would have equaled 0, one of these would have been 0. If the denominator comes out 0, it's not a valid term. Okay? And you'll need to note that in your answer. But this one is x equals 8. You're done. Okay, numbers 2 and 3 are very similar to this. They're a little bit enlarged. I don't know that I will help you with those guys. I guess I could tell you what the least common denominator is. Yeah, the least common denominator for 2 is 30, and for 3 is 6x. Now note that it's 6x, so you have to multiply everything times 6x. Yeah, and then I will go to number 4. I'll just push you over. Or I'll push the screen over. There we go. Not you. I won't push you. Number 4 looks like this right here. Negative 3, x negative 3, 5, x negative 3. Well, guess what? The denominator is the same. Now, you can know that if they put a problem in with the denominator being the same, it should just start automatically. You don't have to find the least common denominator. Well, it should be raising red flags, okay? Just like my shirt's red. So watch out. This problem's got a burr in him, I'll tell you. But here we go. So the way we do this here is you just simply multiply 3 times x and 5 times x3 because the greatest common denominator is x3. So there's not really too much to do here. Just simply work the problem down. 3 times x, take the parentheses off, 3x, and 3 times 3 is 9, it's negative, it's positive. Over here on this side is 5x, and 3 5s is 15. So if you stop right here, I just took that problem and made it into, I just took it off of I multiplied the time the denominator so that it would be a whole number instead of a fraction. Or yeah, a whole number instead of a fraction. So I got 3x plus 9, 5x, negative 15. So go ahead and solve that. The negative 3x, I put the arrow, I brought him over here because it made him positive, so that made me an 8 positive. And then this here was a negative 15, so I brought him over to make him a positive 15. See, everything's working out just perfect, okay? You get ready. I'm telling you, get ready. They don't do things like this here just for jokes. Okay, so you got a negative 15, you add positive 24. Isn't this easy? Positive 24, x8, divide 8 into 8, you got x, 8 into 24, you got 3, and they want you to just, unless you're on your toes, you're to, x equals 3. Wait a minute. Now remember what I told you about that little box? It might not be a valid term. Why don't you put x equals 3? Why don't you put 3 in there? 3 subtract 3 is 0. 3 subtract 3 is 0. What did it tell you? An excluded value is any value that causes the denominator to equal 0. The denominator equals 0. It's not a valid term. Example 4, number 3, x equals 3 or 3 equals x, however you want to say it, is not a valid term. So you better put it in there, not a valid term. Okay? Let's move over to number 5. Quickly tell me, what is the greatest common denominator, no, the least common denominator of number 5? Oh, there you can see it on the board already. No. Well, I won't go to all the steps to tell you how to get that there, but what you would have needed to do is to write out all these in individual terms and then choose the terms that had the greatest value. So you would have chose 2x, you would have chose 2x negative 3, you'd have chose 2x, you chose 4x here, so you chose each one of them. Well, in short, your least common denominator is 2x negative 3, x negative 4. So that means you'll multiply every one of these problems by this here. And so I wrote them out here. I probably won't go through all the steps. I'll show you some of them. So the first one is 2x negative 3. I multiplied it by 2x negative 3. Okay, so if I had put a 1 underneath here, which I didn't do it, you could have canceled. So I could have canceled this one out, and I could have canceled that one out. You see how I could cancel across the corner? So that left me with x negative 4 and 2, and so I would need to multiply those together. What I did, I took that right there and I put it right here. Okay? X, 2 times x. Now I was ready to go to my second term, 4x, and do the same thing. Now it is a subtraction problem there, if you can see. Okay, so if you follow me right here, now I got 2x plus 3, negative 4, my greatest common, and I multiplied it times this. Okay, guess what? I can cancel out right here. I can cancel the x4 and the x4. Both of those I could cancel out. That makes sense? Well, if you put them in improper fractions, if you want to work them that way, that's fine. So that left me with 2x negative 3 and 4. Okay, so I flipped them around. I put my 4 in front, 2x negative 3 here. Okay? Now, if you're still with me here, I still have this number here. I ran out of space here, so I had to keep carrying over. This 4x negative 3, I put him right here, and I'm multiplying by 4x by my least common denominator again. And I've got the 2x3. I can cross that out, cross him out, and I can cross this one out. That leaves me with 4x4. See? So I brought him right here. 4x4. Okay, while we're here, why don't we just solve this one? 4 times x is 4x, 4 4s are 16, opposite side is negative. Okay, we got that one solved. I'll flip back around. 2x, I'll start back over on this side. 2 times x is 2x, 2 times 4 is negative 8. Okay, 4 times 2 is 8x, and 4 3s is positive 12. Now here I did bring my negative sign down. Now I combine these two here next. On this side here, so 2x and negative makes me negative 6x, and 8 negative and 12, I can combine those. I'm subtracting those, and that makes me 16. Okay, yeah, look here, this was subtraction, so that made this 8 a negative, okay? We just put this all in one line, and that left this 8 a negative 8, and then this 12, when you combine the positive 12 and negative 8, you came up with 4. So that brought me down to negative 6, positive 4. And now I come over here on this side, and I had my, I'm a little bit off here, so don't pay attention to this. I brought my negative 6 over here, and so that makes 6 plus 4 makes me 10x. I took my 16 over here, he was negative, that made him positive. 16 plus 4 makes me 20. Well, you follow me how I'm getting my ones on different sides here? So I'm getting the x's isolated over here to 10x and 20 are my two answers. Now, I isolate the x, 10 into 10 makes me x, 10 into 20 makes me 2. 2 equals x. Now again, we'll flip back up here again, and if we would put 2 in this bracket right here, we would go 2 subtract 4 would make us, we're positive 2, so that would make us a positive 2. So that would not equal 0. And here you could go 2 times 2 is 4, subtract 3, 2 times 2 is 4, so you come up with 1. So it does not equal 0, so it is a valid term. Number 5 is a valid term. There's a lot of work here, okay? Number 5 requires you to do numerous amount of figuring. You could have cut a few shortcuts there if you wanted to, but be careful or you'll get mixed up. Number 6 is an example 5, and I'll talk about that next. Can you see there the top of that one? Example 5, and you just take a look in your book there. You have all x terms, and they're identical terms. X negative 2, x positive 2, x negative 1, x negative 6. You can only do this if all your terms are the same. Okay? You can't do this process if you have different terms like some of the others, like we had negative and positive. But if you have a fraction in front and a fraction in the back, the answer is equal. The way you do it is you multiply cross corner. You multiply this away, and then you turn around and you multiply this away. Okay? Be sure to get the correct way, but multiply this away, and so what that does, I bring it right down to here. This is x squared, x5. I put these two here on this side, and then I put these two over here on this side, x negative 7, x positive 1. Now you'll use your formula to find combining, you can do the FOIL method, you can do however method you want to use, but I combine these, multiply these two together and come up with this. I personally use the FOIL method. I did the first terms is x plus x makes me x squared, and then I did the FO, the outer terms, x plus 5 makes me x negative 5, and then I did the inner terms, x plus 2 made me 2, which I combined those made me x negative 7, and then I did my last terms, 2 times 5 is 10 positive. So I use the FOIL method to simplify that and to multiply those together. Here you can do the FOIL method again. You got your x squared, x negative 6, x negative, I'm not going through that step, okay? So here you have your two terms now. Okay, first thing you do, you got x squared on both sides so you can cancel that out. X squared here, you have it there, and you have it here. So when you can bring this one over or this one over, it doesn't matter, you can cancel those out. So that leaves you with negative 7x, positive 10, negative 6x, negative 7. And here again, I looked at the negative signs and I said, I'll take them over to the other side and make them positive. So I took the negative 6 over here. 6, negative 7 leaves me with 1x. Well, yeah, just x. You leave the 1 off. And then I had the positive 10. And I said, well, I got the x on this side. I'll bring him over here. That makes him a negative 10. Negative 7, negative 10 makes me negative 17. X equals negative 17. And now you can check again and put him, let's say, negative 17 here, and see if how that comes out. It does not come out to 0. Or you can put negative 17 here. You want to make sure that it don't come out to 0. You just need to do that little check at the end. Yeah, I hope you make out fine. I know that the first part here, 2 and 3, are pretty easy. When you turn back and do the last ones on 41, 42, in today's lesson, you'll find those to be relatively easy as well. I think you don't have to use step 5 in any of those, I don't think. But yeah, enjoy your lesson, and I will see you tomorrow.